This is my presentation for Lab 2 on simulating tapes with a line charge model. In this lab, we will create a more sophisticated and more accurate model for one positively charged strip of tape floating over another. Our problem is to find a more accurate estimate for the charge on one strip of tape using data we have gathered experimentally and a GlowScript model. This time we will simulate the strips of tape as uniformly distributed charges instead of point charges. In this report, I will first go through the physics principles relevant to this phenomenon, then the physical experiment used to gather the initial values that will be used in the GlowScript model, and then the results will be discussed along with a few other questions. There are two fundamental physics principles at play here. The first is Newton's second law, which states that the change in momentum of an object over time is equal to the net force on an object. So, if the velocity is zero, the net force on the object is also zero. And the second is the principle of superposition, which states that every charge in space creates an electric field independent of the presence of other charges, so any charged objects, such as our strips of tape, will produce an electric field. So for the experiment, I created two positively charged strips of tape and observed their reaction to one another. Because of this, the tape was repulsed by the other strip of tape. In order to be able to measure the charge of the strip of tape, I floated one piece of tape over the other and measured the distance at which they were in equilibrium. This value will be used in the next section. And here is how I estimated Q. When we combine our fundamental principles, we find that the net force on the tape must be zero. So the force of the electric field is equal in magnitude to the force of gravity, and we can estimate Q with the distance gathered a moment ago, and along with algebraically rearranging the formula you can see on the left-hand side. And with this, I was able to estimate that Q equals 1.2 times 10 to the negative 8th coulombs. And here you can see my GlowScript model. Each strip of tape is simulated with 10 point charges. And here are all my constants and initial conditions. You can see I have the K constant and the acceleration due to gravity, and then all of the experimental data, including the distance and the length of the tape, and how I found my initial value of Q, along with my final value of Q, and then how I calculated my percent error. And then here is how I calculated all the individual fields that were added together. And so, what was the magnitude of the charge on one piece of tape as calculated by your computational model? Initially, the value I calculated in Lab 1 was 1.2 times 10 to the negative 8th coulombs. But as you can see in the photo, that cannot be true because it would result in a much smaller force of electricity than was observed. So to fix this, I used the guess and check method until I found a value of Q that was closer to reality within the line charge model. The new value is 2.9 times 10 to the negative 8th coulombs, which gives me a 140% error from Lab 1. And here you can once again see the magnitude of the force of gravity and the force of the electric field are about equal. So why do these estimates differ? Which value is more likely to be closer to the real value, and why? These estimates of the magnitude of charge differ because they are calculated with different models. The point charge model only takes into account the y components of the force of the electric field, while the line charge model has to take into account the x and y components of each piece. Because the line charge model is closer to reality, the number it produces will be more accurate. What assumptions did you have to make to determine the amount of charge on the floating tape? In Lab 1, I treated the tape as though it were 1 point charge, but for Lab 2, I treated each tape as 10 point charges, which is closer to reality but still ultimately an approximation. I did assume that each U tape had about the same amount of charge, evenly distributed along the length of the tape. In conclusion, in this lab, I estimated that the charge of one strip of tape is 2.875 times 10 to the negative 8th coulombs. I did this with a more accurate line charge model. If I wanted to make my estimate more accurate in the future, though, I would use a greater number of point charges to simulate evenly distributed charges. Thank you.